Okay, now we're going to deal with side 2, problems number 3 and 4, dealing with completing the square. Completing the square is going to be used to solve these equations to find what values of x make these equations true. And the time to use completing the square is when the leading coefficient is 1. So that will be the best time to use it. In this case, completing the square, what we want to do is get the x term and the x squared term on one side and the constant on the other. So in this case, in order to do that, we have to add 5 to this side to get rid of it from here. And so you add 5 to both sides. And then we're going to complete the square. Now in completing the square, we want to take the b term, or the x term, and we're going to cut that in half, and that is going to be squared. So we're going to cut the 4 in half, and then that 2 is going to be squared. But what we do to one side, we have to do to the other. So if we add 2 squared here, we've got to add 2 squared here. It keeps them balanced, to keep both sides balanced. And then we take a perfect square trinomial and we're going to factor it. And if you don't know or understand the principle behind this, you need to then find a video on factoring perfect square trinomials. So it'll give you more understanding about why this works. So basically what happens, we take the square root of the first term, which is x, take the square root of the last term, which is 2. So it's whatever this number is being squared. And then, and it's a positive, so there we go. And we're going to square that binomial. If we were to square this binomial, we'd end up with this perfect square trinomial. And then 5 plus 4 is 9. And then we're going to take the square root of both sides. And so this is going to be, this is actually going to be plus or minus the square root of 9. And so we are going to then end up with x plus 2 equals plus or minus 3. And so we get x by itself by subtracting 2 from both sides. And so we get plus or minus 3 minus 2. Then, so x could be one of two things. It could be the plus 3 minus 2, or it could be the negative 3 minus 2. So therefore, x equals 1, or x equals negative 5. And then to check that, if you put the 1 up here, you have 1 squared is 1, plus 4, which is 5. 5 minus 5 is 0. If you take the negative 5, you get negative 5 squared, which is 25. And then 4 times negative 5 is negative 20, so minus 20, minus 5, and does that equal 0? So 25 minus 20 is 5, minus 5 is 0. So both of these make this equation true. Let's go to number 4. Number 4, we want the x squared term and the x term to be by themselves on one side. And so we have to subtract 24 from both sides in order to make that happen. What you do to one side, you have to do to the other. Then we're going to complete the square by, as I said with this other problem, if you don't understand the principles behind completing the square or why a perfect square trinomial factors to a binomial square, you need to find the videos that deal with that kind of thing. We're basically going to cut this negative 10 in half, and and it becomes a -5, and then we're going to add that. We're going to square it. And so we're adding half of this squared. And what we do to one side, we have to do to the other side. Okay, so this factors to a square, a binomial squared. Square root of the x squared is x, and then square root of the -5 squared is just -5. And then this is -24 plus 25, which gives us a 1. So we take the square root of both sides. So we will then take the square root of this, so something squared, take the square root of that, it's just going to be what you started with, so it's x minus 5, and that's going to equal the plus or minus 1. Add 5 to both sides, so x is by itself. And so x equals either 5 plus 1 or x equals 5 minus 1. And so x equals 6 or x equals 4. And then you can always check those to make sure they're true. And so you can, if you put 6 in for x here, you'll find it'll make this true. And if you take the 4 and put it in for x, you'll find it makes that equation true.